Hello there, Mr. Sutton here, bringing you the MCAS 2024 solutions. This is part 1 of a 2-part video series. This one goes through questions 1 through 21, which is the no calculator section. For this first question, we have an arithmetic sequence represented by this f of n function, 3n plus 1. We want to know which of the following sequences down here is represented by this function for n equals 1 through n equals 4. So if you're not sure what an arithmetic sequence is, one thing you can do on this is just simply plug in the n value 1 into this function to see what we get. So that would be 3 times 1 plus 1. 3 times 1 is 3. 3 plus 1 is 4. And then if you're still not sure what to do, well, let's plug in n equals 2. So we have 3 times 2 plus 1. That's going to be 6 plus 1, which is 7. And you can keep doing this, and you'll at some point find the pattern here. We're basically just adding 3 each time to get this result, which makes sense because you're just multiplying 3 by an increasingly bigger number each time and keeping everything else the same. So if I keep adding 3, we started with 4. 4 plus 3 rather is 7. 7 plus 3 is now 10, which I could have gotten by doing 3 times 3 plus 1. 10 plus 3 gives us 13, and we could keep going as long as we wanted to, but the answer choices only have 4 numbers in them, and it's looking like choice B has the numbers that we just described here. For number 2, we have 2 numbers represented by variables. X represents a non-zero rational number, while y represents an irrational number. And we need to figure out whether the value of each of these expressions down in this table is rational or irrational. I think the easiest way to do this is actually to pick 2 numbers that match those descriptions and see what happens when we do these various operations with them. So for a non-zero rational number, well, rational is anything that can be expressed as a fraction, and this also includes whole numbers, like the number 2. So I'm going to let x equal 2, and that'll be my stand-in for all rational numbers for this problem. And then for y, an irrational number, well, if you take the square root of a number that is not already a perfect square, such as 2, the square root of that is going to be irrational. So I'm going to let y equal the square root of 2. Now there's other irrational numbers out there. Some of you might be thinking, hey, pi is a good number to use, but as you'll see down here, that might muddy the waters a little bit. So let's just use the square root of 2 for now. So for my first expression, x squared, that's going to be 2 times 2, 2 squared. That's 4. 4 is a rational number, so we'll put rational for that one. Now x times y, that's going to be 2 times the square root of 2. If you take an irrational number and multiply it by a rational one, you're always going to get, unless you're multiplied by, I should say, a non-zero rational number, you're always going to get another irrational number. This is an irrational one right here. And then finally, 2x plus y, that's going to be 2 times 2 plus the square root of 2. So that is going to be 4 plus the square root of 2. And if you take an irrational number and add a rational number to it, you get another irrational number. So that one's also irrational. For number 3, we're asking which of the following equations represents a line that has a positive slope and a negative y-intercept. So we've got all these line equations that are in standard form, and we would prefer them to be in this y equals mx plus b slope-intercept form so that we can easily pick out what the slope is and what the y-intercept is. Now the good news is to get all of these in that form, you really just have to get y by itself, which on all of these I can do by just moving this first x term over to the other side, by either subtracting it or adding it. So for this first one, if I subtract 3x, that gives me y equals negative 3x minus 6. And from this we see that we have a slope of negative 3, which is a negative number. And then we also have a y-intercept of negative 6. That b value is going to be your y-intercept, so negative 6 is also negative. Next up, this one we can subtract the 3x to get negative 3x plus 6. Slope is still negative 3, so negative. The y-intercept is positive 6 now, which is positive. And then for this next one, we have 3x being added over to the other side to give us 3x minus 6. Now our slope is positive 3, which is positive. Y-intercept is negative 6, which is negative. And finally, for this last one, we'll add the 3 to get 3x plus 6. So now we have a positive slope and a positive y-intercept. Now what was the question again? They wanted the one that had a positive slope and a negative y-intercept. So positive slope is these two choices down here, C and D. And between those, the negative y-intercept was choice C right here. For number 4, we have these parallel lines, K and L, that are cut by this transversal, and they've labeled the 8 angles that are formed by this. They're telling us that the measure of angle 7, which is right here, is 50 degrees, so I'm going to label that in my diagram just to have it. They want the measure of angle 2, which is all the way over here on this other street corner. So this is going to take us, let's see here, there's a few ways to do this. So probably the easiest way for me intuitively is to figure out the corresponding angle and then match that up with angle 2. So angle 6 and angle 7, those are on opposite street corners. Those are called vertical angles. We know that vertical angles are congruent. So this angle 6 also has to be 50 degrees. Another way you could have gotten there is to say, okay, 7 and 8 are supplementary. They add up to 180. So that would give you 130 for this angle, and then that's the same relationship with 8 and 6. 130 and 50 would also give you 180. Now moving ahead though, we can look at angle 2 as the corresponding angle as angle 6. It's the same corner on a different street, so to speak. So we know that corresponding angles are going to be congruent. So that means angle 2 is whatever angle 6 is, which is to say 50 degrees. So that's going to give us choice B, 50 degrees. This next question is a system of linear equations. So it's kind of awkward the way that they're asking this one, because rather than saying what is the solution to this system, they are asking which of the following systems of equations has the same solution as the given system of equations up here. So a little bit weird. You might be thinking, oh, well, I have to solve this one, and I also have to solve all of these these systems, and then match the ones that have the same solutions. You could do that. There is a faster way, though. If you just take a quick look at these answer choices, you'll notice that in each of them, we have one of the equations as x equals a number. And more than that, if you take a closer look, we see that x equals a different number in each of these different options. So if we could figure out what x equals from this system up here, we could very quickly match that up with one of these systems down here. So that's going to be my strategy. So when I'm going ahead and solving this, there's a lot of different ways to solve systems. I'm going to try to do it in a way that gets me the value of x as soon as possible. So one option we could use here is to try to use elimination and get rid of these y's and then solve for these x's. So if I want to get rid of these y's, I see I have a 2y and a 1y. So I'm thinking if I were to multiply this bottom equation here by negative 2, I could get this to be a negative 2y, which would cancel out the positive 2y. So that's what I'm going to try to do here. I'm going to keep this top equation exactly the same. This bottom one I'm multiplying by negative 2. And if I do that, I've got negative 4x, negative 2y, which is the reason I used negative 2, and then this happens to be negative 10. Adding these together, these two y's are canceling. We have 3 and negative 4 gives us negative 1x, and then 8 and negative 10 adds up to negative 2. Well, dividing each of these by negative 1, I have x equals 2. And now I look down here and I see that x equals 2 is choice A, so I'm going to go with that one. I could, again, go ahead and solve this and solve this and solve everything, but I know enough to pick one of the answer choices, so it's time to get on with life. For this next problem, number 6, this is actually the first of our multi-step open response show your work type of problems. In this one, we're given the price in dollars of 10 magazines for sale at some newsstand, and here are those prices. We want the range of the prices in dollars of the 10 magazines with work. So One thing that is important to notice here is if you look at these, they are actually already in order, which is going to help us with a lot of the things that we're trying to figure out with these. So to find the range, in general, you're doing highest minus lowest value. The highest value, since these are in order, is already at the end here. It's 10. Lowest value is 7. So the range is just going to be 10 minus 7, which is going to be $3. For part B on this one, they want the median price of the 10 magazines and show or explain how we got the answer. So for this one, we're going to be crossing off all the numbers in pairs from highest and lowest, and we'll just keep doing that until we get to the middle two numbers. So the 7 and the 10, we can cross those off. 750 and 850. 750 again and this 8 right here. And then this 750 and this 8. That leaves us with an 8 and an 8 in the middle. So we don't probably need to do this next step, but if these were different numbers, you would want to add them together and divide by 2 to find the mean, and that would give you the median if you've got two numbers in the middle. If it's one number, it's just whatever number is there. Now, just to be kind of complete here, I'm going to do 8 plus 8 divided by 2 equals 8, but I think we already kind of knew that going into this. So our median is going to be $8. For part C on this one, we're going to be adding 2 new magazines for sale at the newsstand. Exciting news. Each new magazine is going to have the same price, so they can't be different prices, and the prices of both will be included in the list. All right. Also, the median price of all the magazines, including the new 2, is not going to change. What could be those new prices? And show explain how we got the answer. So if we don't want the price, the median price, to change, then we would like to pick prices that are either as close to the median as possible or are the median. We're going to go with prices that are the median. If we use the median price, then when we line these up again, the middle price is not going to change. So we would have an extra 2 magazines that are each worth $8, and then the new middle would just be like halfway between the 2 new 8s that are in the middle. So we're going to go with $8 for the new prices of those 2 magazines. For part D, they're trying to increase the mean price of all these magazines by $1 by adding 2 new magazines in there. And we need to find the actual price of those 2 magazines. And although they didn't quite specify it, I think if they're talking about sort of like the magazines from before, that these have to be the same price, just like in Part C. So before we can figure out the price of the new magazines, it might be helpful to know the mean of the original 10 magazines. So I'm just going to add all 10 of these together, divide by 10, and see what that comes out to. And then we'll increase it by 1 and go from there. So we've got 7 plus, and I'm just going to shortcut this a little bit, 3 times 7.5 plus 4 times 8 plus 850 plus 10, just condensing it a little bit with some multiplication. And again, we have to divide that by the number of magazines we started with, which was 10. All right, so this is, let's see here, this is going to be 2250 if I multiply this by 3, and this over here, 4 times 8 is 32. So we've got 7 plus 2250, that's going to be, let me think here, 2950. 2950 plus 32, let's see here, that would be 5950 plus another 2 would be 6150. 6150 plus 850 would be 70, and 70 plus 10 is 80. So I did all that in my head, but obviously if this is the real MCAS, you probably want to do it out on paper just to double check. So we have 80 over 10, which is going to be $8 for the original mean price of these magazines, which seems reasonable given the numbers here. So now we want to increase this by $1 by adding 2 new magazines in there. So the way I'm going to set this up is if I take my original price, which was 80, and add 2 times some mystery number to it, we'll call it 2x, and divide all that by 12, we should end up with $9. So $9 is our target. I've got the original price of 80 plus 2 mystery prices divided by 12. And now all I have to do once I've set this up is solve for x. Okay, well, first thing I'm going to do is multiply both sides by 12. 12 times 9, that's going to be 90 plus 18, that's going to be 108. And then 108 minus this 80, that's going to be 28. That's not too bad. And then 28 divided by 2 gives me $14 for each of those new magazines. For this next problem, we have lines represented in different ways. We have this linear function here represented algebraically, that's f of x, and g of x is represented by this graph. These are both linear, just different forms. So they want us to compare the slopes and the y-intercepts of the two functions and draw some conclusions, which we will put down here. So first off, they want to know if the slope of f of x, that's this function right here, is positive or negative. So the slope, since this is in y equals mx plus b form, the slope is this m value of 5 over 4. That is a positive number, greater than 0, so we'll put positive in here. Next up, the slope of g of x on this graph. Well, g of x is going down, so clearly the slope must be negative in that situation. But if you wanted to find the exact slope, it looks like we're going through grid lines at 0, 2, and if we follow it a ways, our next crossing of the grid lines, where the grid lines intersect clearly, is over here at 7, negative 1. So we're going down 7, right 3. That's a slope of negative 7 over 3. Or negative 3 over 7, I should say, down 3 over 7. Either way, it's negative, so that's negative. Next, they want us to compare the y-intercepts of f of x and g of x to see if which one's bigger than the other. So for f of x, we've got this negative 7, that's the b value, that's our slope there. And for g of x, our y-intercept, which we read off the graph, is this 2 that we're crossing the graph, the graph is crossing the y-axis at. So we've got negative 7 versus 2. Now negative 7 is less than 2, so the y-intercept of f of x is less than the y-intercept of g of x. For number 9, they're giving us the equation of a circle here, and they want the coordinates of the center of the circle. So for something that is in the form of x minus h quantity squared plus y minus k squared equals r squared, the center is always going to be this h comma k. Now the key here is realizing that in this formula, h and k are both being subtracted. So whatever you see in the actual formula up here, the equation up here, you have to remember to reverse the sign of whatever numbers you see in those parentheses. So my x value of my center is going to be positive 1, because this is minus 1. And over here, we can think of this as y minus negative 2. So my k value, then the y value of my center is going to be negative 2. And 1 comma negative 2 is going to give me choice C. For number 9, they're giving us a table, and they're saying that this is a linear relationship between x and y, and they want the equation that describes the relationship in the table. So these equations are all in either mx plus b form, kind of, sort of, it's more like b minus or b plus mx, but whatever, or they're in some kind of weird point slope sort of form. So if I can find the slope, that would be a good starting point for this. That might at least narrow it down a little bit. So let me do the slope formula, y2 minus y1 over x2 minus x1. And to do this one, you just have to pick 2 points out of the table. It doesn't really matter which 2 points you select, as long as you're consistent about using them. So I'm just going to use the first 2 points, because why not? So for y2 minus y1, I've got 3 minus 5, over, for x1, x2x minus x1, I got 2 minus 1. So this is negative 2 over 1, which just reduces to negative 2. Now I'm going to use point slope to get an equation because I don't know what the y-intercept for this thing is. I could figure it out, but I would just as soon start with point slope and go from there. So here's point slope. Y minus y1 equals m times x minus x1. And I'm going to use the first point in the table with the slope that I just found. So for my y minus y1, I'm doing y minus 5. And again, I could have used any of these y values, but then I just have to be consistent about the x value. Next up, my slope was negative 2. Then I have x minus this first x value here, x minus 1. And the knee-jerk reaction is to pick choice B because they look awfully similar, especially if you add this 5 over to the other side. But if you do that, you'll see that this is the wrong sign for the slope. This is supposed to be a -2 here. So what we're going to do instead is distribute this -2 and simplify this as much as we can to hopefully get one of these other answer choices. So distributing that, we got -2x over there, and then -2 and -1 gives me +2. Next, let me just move this 5 to the other side by adding it. So we have y equals -2x plus 7. I could also write this as 7 minus 2x, which would match answer choice C. For number 10, I have to combine these polynomials. First thing I'm going to do is get rid of these parentheses. The first parentheses has an invisible 1 out in front, so I can just get rid of that for free, basically multiplying everything by 1. So nothing changes there. For this next one, I'm distributing an invisible -1 to each thing in this parentheses. So this is going to be minus 5x squared, minus 3x, and minus minus is plus 4. For my next step, kind of optional, but I'm going to put the like terms next to each other. So 3x squared and minus 5x squared. Next, -4x and -3x. And then finally the 9 and the 4. Combining these, we end up with -2x squared. This will be -7x. And then finally 9 plus 14 is going to be 13. And that is going to match answer choice C. Or D. It's D. C had a negative, had no negative out in front, so it's going to be D. Yep, there we go. For 11, this one's got a couple parts to it. For this first part, we have this triangle being translated according to some rule to create triangle DEF, which they're not showing. They are telling us that the coordinates of point E are 2, 1. So let me put that on the graph here, 2, 1. There we go. Now they want to know which rule translates triangle ABC to create triangle DEF. So one thing that you have to kind of understand with these transformations is that the letters are written in a specific order. A turns into D, point B turns into point E, and point C turns into point F. So if we're told that E is 2, 1, then we're basically trying to figure out what happened to point B to give us point E. So here's point B on the original graph. We went right some distance here, and then we went down to get there, if it's a translation. Specifically, we went right 5 and down 2. So we need to find an algebra way of saying right 5 and down 2. For right 5, that's going to be x plus 5. Down 2 is going to be y minus 2. So x plus 5, y minus 2 is going to be choice D. For part B of this question, they're telling us that ABC is going to be rotated 180 degrees clockwise around the origin to create A prime, B prime, C prime. They just want us to draw that on this coordinate plane. And on the actual MCAS, they gave you like 4 different choices to draw it out. All right, so the key here is realizing that a 180-degree rotation, whether clockwise or counterclockwise, it's the same thing, simply changes the sign of x and y. So I'm going to write out my original 3 points, then I'm going to make those changes, get 3 new points, and graph it out from that. So here's my original 3 points. For A, we had the point -4, -1. For B, this is -3, 3. And then for C, this is -2, -2. And again, we said we're going to change the sign of x and y, so -x, -y. So changing all the signs, let me just do all the x's at once. This is going to be +4, +3, +2. And then for the y's, I'm now going to have +1, -3, +2. And then going back to graph those out, 4, 1, that's 4, 1 right there. 3, -3 is down here. And then finally 2, 2, easy to graph that one, put it right up there. And then just connect the dots. And there's your new triangle. For this problem, we're trying to find solutions to this equation here. Now, since this is already factored, we can use our zero product property set each of these factors equal to 0, and solve them individually. So I can split this up into two equations, one where I'm trying to find the solution of 4x equals 0, and the other, x minus 8 equals 0. For this first equation, I just divide both sides by 4, and I get x equals 0. And over here, I can just add 8 to the other side and get x equals 8. So we have 0 and 8. 0 and 8 is going to be choice C. For number 13, we've got three students, Alice, Clive, and Denise, studying exponential and radical expressions and equations. Good for them. Alice writes this expression, 64 to the 1/3. We want to know which of the following is equivalent to that expression. So when you have a fractional exponent, the general rule is that the power is, the numerator is really the power, and the denominator of this fraction is the root that's involved. So as a general formula, I can write x to the p over r equals the r root of x to the p. In this case, if I have 64 to the 1/3, that's going to be the cube root, because we have 3 in the denominator, cube root of 64 to the first power, which is just cube root of 64 to the first, which is choice D. For part B, we want the actual value of Alice's expression of 64 to the 1/3, or cube root of 64. So the cube root of 64 is the number I have to cube to get 64, the number I have to raise to the third. So if I raise 4 to the third power, 4 times 4 times 4, that's going to give me 64. Therefore, the cube root of 64 is going to be 4. For part C, we have Clive writing this expression, the 5th root of x to the 7th, and he wants to rewrite this expression with a rational exponent with x to the p. So we want the value of this p. So basically, you just have to rewrite this as a fractional exponent, and then whatever that fraction is, you just write p equals that fraction and call it a day. So using our format again, remember that the power inside here is the numerator of the fraction. The root is the denominator. So we can rewrite this as x to the 7/5 power. And if we have x to the 7/5, that means x to the p equals 7/5, or p equals 7/5. For the final part of this question, we have Denise writing this equation, n to the 1/2 to the 2/5 equals n to the 1/2 times n to the 2/5, kind of like a fancy distributive sort of property applied to exponents or something like that. Denise is claiming this is true for all positive values of n. Is that correct? So we're going to show that this is in fact not the case. So this is a no, and here's why. The general rule for when you have x to some power raised to another power, we'll call it x to the a to the b, is that we have to multiply the exponents. So we could write x to the a to the b equals x to the a times b. So in this case, n to the 1/2 to the 2/5 is really n to the 1/2 times 2/5. If we cancel out these 2's here and then just multiply straight across, we have n to the 1/5. So that's what this should come out to. Now let's take a look at this expression here, n to the 1/2 times n to the 2/5, and see if that actually comes out to n to the 1/5. So when we multiply the same bases together, we have to add the exponents. So this is really n to the 1/2 plus 2/5. Now, if we're adding fractions together, we have to get a common denominator. The common denominator for 2 and 5, one of them anyway, is 10. So I'm going to rewrite 1/2 as 5/10 and 2/5 as 4/10. And if you're wondering how I did that, I just multiplied the 1/2 by 5/5 and the 2/5 by 2/2. In both cases, I'm really multiplying by 1, so I haven't changed the value. Now, if I add these together, adding the numerators, keeping the denominator the same, we have n to the 9/10. 9/10 is a different exponent than 1/5, so these expressions are not the same. Or at least they're not the same if you're plugging in positive values of n, all positive values. Now, we could be kind of crafty and plug in 1 to both of these, and they would come out the same, because 1 to any power is going to equal 1. But if you plug in anything except for 1, these will not be the same. So this proves Denise's claim is incorrect. For number 14, we've got this little survey going on here. Ninth graders and 10th graders were asked about the number of glasses of water they drink each day. Hopefully it's a lot. Water's good for you. This table is showing the results of all this. So we have two rows here, one for 9th graders, one for 10th graders. And we also have another row for the total. And then we have 4 columns, 0 to 2 glasses, 3 to 4 glasses, and 5 or more glasses, and then the total. So first question here is, based on the table, what is the probability that a randomly selected student from the survey drinks 0 to 2 glasses of water per day? So something to focus on here is the wording, a randomly selected student. So we're not being specific about how old the student is. So that means that we're taking our number from this total row here. So we want the total number of students who had 0 to 2 glasses a day, which is this 19 right here. Next up, we have to figure out the denominator. This is 19 out of how many students? Now again, since they didn't specify an age level for the students, we have to assume it's out of the total students that they surveyed, this 82. So that means that our probability is going to be 19 over 82. And if I look at my answer choices, that's going to be choice C. D was close, but it was upside down. And it's kind of weird because you can't have a probability of bigger than 100%. So C it is. For part B to this question, they want the probability that a 10th grade student drinks 5 or more glasses of water per day. So we have 10th graders drinking 5 or more glasses. That's this 17 right here, where the 10th grade and the 5 or more columns and rows intersect. And that's going to be out of how many students? Now, because of the way they worded it, they said probability that a 10th grader drinks this. We're assuming that we have a 10th grader to begin this question. They didn't say the probability that a student is a 10th grader and drinks 5 or more glasses. They specify that it has to be a 10th grader that we're looking at. So that means that we're looking at this, only the 10th grader total, 37, instead of the total for everybody. So that means we're going to have 17 over 37 for this probability. For this next question, we have this isosceles triangle, PQR, and we're asked which of the following transformations would not create a congruent image. So we have a 270-degree counterclockwise rotation, a dilation with a scale factor of 2, a 180 rotation, and a reflection over one of the sides, side QR here. Now the thing about congruence, if you rotate or reflect or translate, they didn't do any translations, but if you translate an object, you're going to create an image that is still the same shape and size, still congruent. The only transformation that changes the shape or size of an image is a dilation. So in general, we can say rotations, reflections, and translations don't change an object size, but dilations do. The only choice with the dilation is choice B, and it's a scale factor of 2, which is important. If it was a scale factor of 1, we would actually just be keeping the image the same. But since it's 2, we're multiplying all the dimensions by 2. That changes the size, so this would not give us a congruent image. So choice B. Here we are with number 16. Somebody spent a lot of time creating the pictures for this one. We have a cross-section of a speed bump, and we've got a car going over it, and we've even got the equation for the speed bump, because I'm sure that's how they design and install these things. This one is f of x equals negative 0.0625 x squared plus 0.25. So let's see here. We've got x and f of x representing different measurements in feet. So x is the left-right, y is kind of the vertical measurement of this speed bump. And for the actual question, after all of this information, they want us to calculate the value of f of 0 and say what that actually means in real life. So for f of 0, this is fairly straightforward since we actually have the function here. We can just plug 0 in for x and see what this evaluates to. So if I plug 0 in for x, here's what that looks like. We've got negative 0.0625 times 0 squared plus 0.25. This is really nice here because 0 squared is 0, and 0 times anything else is 0. So this really just leaves us with this 0.25 left over. So we've got 0.25 for f of 0. We'll put that in there. And now what does that represent? Well, f of x gives you the height, it looks like, of the speed bump at any x value. So this is going to be the maximum height of that speed bump is going to be about 1/4 of a foot, or 3 inches. So we'll put height here for our little blank. For number 17, we have Dwayne earning $607.50 for 37.5 hours of work. Which of the following is closest to the amount of money he earned per hour? So one thing to keep in mind on this problem, this is in the no calculator section, so we basically have to estimate this. And the best way to estimate the total is by estimating these original amounts. So 607.5 is pretty close to 600, so we'll call that 600. And then 37.5, that's pretty close to 40. I'm going to call that 40 hours. Now, the money he earns per hour, we get that by dividing the total dollars by the total hours. So 600 over 40, which is going to come out to, let's see here, 60. You could cancel these zeros, so we just have 60 over 4, which is 15. So roughly $15 per hour. That's not any of the answer choices, but it's pretty close to answer choice B. So I'm going with that one. For question 18, part A, we're asked to consider the inequality y less than or equal to 3/2 x minus 4, and basically figure out which graph represents that. So there's 4 different traits I'm going to take a look at. 2 are the actual characteristics of the line itself that we're graphing, and 2 are characteristics of the inequality. So looking at the line, first thing that draws my attention is this -4. This is the y-intercept. Looking at my graphs, which one has a y-intercept of -4? For choice A, it's 2. We have, this looks like maybe -2 or -1, kind of hard to tell, maybe -1/2 for B. It's not -4. C has a y-intercept of -4, and then D has +4. So just on this basis alone, it looks like we could pick choice C. But let's look at some other stuff just to make sure that we haven't messed up the y-intercept. So another trait is this 3/2. That's the slope of this line. So let's look at choice C. We're going up 3 over 2, so that tracks. And now the equals under the inequality tells us that this is going to be a solid line, not a dotted line. These are all solid, so that also makes sense. And the less than, instead of greater than, y less than means we're going to be shading below the line. In choice C, it looks like we are shading underneath this line. So this all points to choice C. For part B of this question, we're given this inequality, and we're told that it goes through the point 0, -b. -b sure looks like -2, but if you look down in these answer choices where they're trying to ask which inequality is represented by the graph, there's no -2s. There's lots of b's, though, so we're going to keep this b around. So in order to figure out which equation we're dealing with, I'm first going to get an equation for the line itself, and then I'm going to figure out how to turn that into an inequality. So for the line, I want the y-intercept and the slope. The slope, it looks like, we're going down 1, right 3, so that would be -1 over 3 for a slope. And for the y-intercept, my b value in y equals mx plus b form is just -b, because that's this y value here. So b equals -b, which is kind of weird to write. But for my equation, I can write y equals -1/3 x minus b. So that's the equation of this line without worrying about the inequality piece. Now, since this is a dashed line, our inequality is not going to have an equals in it. And since we shaded above here, that means I need greater than for my y inequality. So I'm going to rewrite this as y greater than -1/3 x minus b. Let's see if that's any of the answer choices. So we have y less than and y less than here. Then we have these other two that have 3y greater than. Since I don't have any matches yet, I'm going to try and match this with a or b. And I think I can do that if I just multiply everything by 3. Because if I do that, I'll have a 3y on the left side, and then let the chips fall where they may on the right side of this inequality. So this is going to give me 3y, and if I multiply by a positive, that does not reverse the direction of the inequality, so we'll just keep that as greater than. -1/3 times 3 is -1, so I can call this -1x, and then minus 3b. Does that match anything that we have in the answer choices? Looks like it matches A. We have 3y greater than negative x minus 3b, so choice A it is. For number 19, we have these polynomial expressions and factorizations for them. So you could FOIL each of these out, multiply each of these out, and see what they give you. But these are all actually kind of shortcuts as well. So if you recognize the shortcut, you can immediately pick one of these factorizations. This difference of squares, x squared minus y squared, you get that by multiplying conjugates together, which is to say the same stuff in the parentheses but with opposite signs. So this x plus y, x minus y, gives us x squared minus y squared. Now for the next one, x squared minus 2xy plus y squared, we're going to get that by multiplying x minus y by itself. This is really x minus y quantity squared. So that's this one over here. And then this last one is kind of the same idea, but you have x plus y times x plus y, so this first one here. For this problem, they're asking which of the following equations represents a line that passes through the point 2, negative 3 and is parallel to this line represented in the graph up here. So be very careful. They are not asking for the equation of this line up here. They're just saying, hey, there's another line that's parallel to this one and goes through this other point. What is its equation? So I think we're going to use point slope to initially write the equation of the line, because they're giving us a point here that is not the y-intercept. Before we can do that, though, we need the slope of this original line. So taking a look at this, it looks like we're going, let's see, down 1, right 2, if I take a look at where I'm intersecting intersections of grid lines. So we have a slope of negative 1 over 2, or negative 1/2. Now I'm going to use my point slope form. So this right here, y minus y1 equals m times x minus x1. So I'm going to have y minus the y value negative 3, so y plus 3. And then we've got our slope of negative 1/2. And then finally x minus the x value 2. Taking a look at my answer choices, none of them are in this form here. They're all in slope-intercept form. So I'm going to simplify this, move this 3 over here, and hopefully find something that matches what they gave us. I'm going to start by distributing this negative 1/2 to this parentheses. So this is going to be negative 1/2 x, and then negative 1/2 times negative 2 is positive 1. Next, just one more step, I'm going to subtract 3 from both sides. That'll give me a negative 2 over on the right side. So we have y equals negative 1/2 x minus 2. Does that match anything? It looks like that matches choice A, so let's pick that one. For number 21, the last question of the no calculator section, we are told that a student incorrectly solved an equation. The equation and steps the student used are given below here. We want to know in which step of the table does the student's error first appear. And I guess first is kind of important because if you mess up something early in the problem, then the rest of it's going to be wrong too. So let's just go through step by step and see where they made a mistake. So for our first step, it looks like they distributed this negative 2, which is what you should do in this situation. Negative 2 times 3x would be negative 6x. Negative 2 times 1 would be negative 2, and everything else is unchanged. So this step appears to be correct. So let's move on to step 2. Here, it looks like they moved things around to get the x's on the left side and the constants on the right side. So to get this 3x over to the left, you would have to subtract it, which is what they've done here. To move this negative 2 over to the right, you would have to add 2 to both sides, which is what it looks like they did there. So far, so good. That's fine. Next up, we're going to combine like terms on each side. Negative 6x minus 3x gives us negative 9x. That's good. Negative 20 plus 2 is negative 18, so still good. Well, by process of elimination, they must have messed up this step. So what exactly went wrong? At this point, they were supposed to divide both sides by negative 9. Negative 18 divided by negative 9, since it's a negative divided by a negative, would have given us a positive 2, not negative 2. So there's a sign mistake there, which confirms that step 4 is the problem and choice D is the answer.